the topic laws of motion, concepts, problems we'll deal today. My dear students, we learn the chapters like motion. Motion is straight line, motion is plane. In those chapters, we learn about the concepts like distance, displacement, velocity, acceleration, acceleration due to gravity. But how the body moves, what is the cause of the motion, we didn't discuss. We only learned that body, how much distance and displacement covering, speed and velocity, how much it is attaining, what is the acceleration, all those things we learned. But we didn't discuss about the how, what is the cause of motion. That one we have discussed in this chapter called dynamics, where definition of force is introduced theoretically as well as measuring the force quantitatively. So let us do the theory part first before going to numericals, concepts, laws of motion. Laws of motion, concepts. First law. These Newton's laws of motion, Newton's law of physics, and you have seen with some experiments happening falling on the earth. He found out there is a gravitational attraction is there which is happening on the earth. We learned in school classes, force is nothing but pull or push. Pulling a body or pushing the body. That is what we learned. So what is the first law? Newton's first law. Newton's first law is every body continues to be in state of rest. Continues to be in state of rest. It is state of rest. Continues to be in state of rest. State of rest means velocity is zero. State of rest or state of uniform motion. State of uniform motion. Uniform motion means what? Velocity is constant. Velocity is constant. In this, first law tells that in the absence of external force, the external force, resultant external force is zero. Resultant external force is zero. Resultant external force is zero. One second. Right. First law says that if external force is zero, external force is zero, resultant external force is zero. Resultant by your telling, there may be number of forces acting on a body. There may be number of forces acting on a body like this, like this, like this. Number of forces are acting on the body like this. So even then body is at rest. Body may be at rest. Body at rest or moving with uniform velocity. External force is zero, body at rest, body moves with uniform velocity. Body moves with uniform velocity. Uniform velocity means velocity remains constant. First law gives the concept. This is called first law. This will not be very mathematical formula. First law gives concept called inertia. First law gives concept called inertia. Gives concept inertia. What is inertia? The body, a person wants to, if he is remaining at rest, he tries to remain at rest. If he moves with uniform velocity, tries to move with uniform velocity only. He wants to remain in its own state. That is called inertia. Inertia. Mass is the measure of inertia. In straight line motion, mass is the measure of inertia. More the mass is the measure of inertia. You are having inertia. Let us say lorry and car is there. Lorry is having more mass, more inertia. Car is having less mass, less inertia. Like this. Inertia, there are examples you learn in both classes. Inertia of rest, inertia of motion, inertia of direction. In inertia of rest, a simple example today. Suddenly, in a system of bus, you are at rest, completely at rest. When bus suddenly comes to motion, passenger falls backward because if he is in contact with the bus, what will happen when it comes to rest? The upper part of the body will not be because of this. Similarly, inertia of motion. Let us say bus while in motion makes sudden brakes, passenger falls forward due to inertia of motion. These are the examples. So, this inertia. Let us go to second law. Second law is very, very important to deal the problems. This first law, Galilei also did experiment. So what it inclined plane he has taken. Let us say you drop a body, it comes down with a velocity v. The inclined surface, Galilei has done like this. After reaching the body here, the body moves with continuously same velocity, uniform velocity, provided this is smooth. Provided this smooth, it will not stop anywhere, goes to infinity. But generally that will not happen. Friction will be there, that's why body ultimately comes to rest. Those are all the things we will see in the second law we will see to it. Second law. Friends, this is very important. Second law measures force, mathematical definition of force. To learn second law, we are learning momentum now. Momentum. What is momentum? Momentum. Momentum is given by the letter P. It is equal to m into v. What is m? Mass of the body. V. Velocity. Momentum is a vector. So you have to keep simple. For example, you have to know the vector notation. Sometimes some problems will be done. Vector notation, if it is two-dimensional motion. One-dimensional motion, same direction, opposite direction, algebraic signs you can take. Momentum is a vector, by vector, m is scalar, mass is scalar, velocity is vector. So momentum is vector, SI unit is kg meter per second. This is kg into meter by second. This is SI unit of momentum. Momentum is a vector. So after this, why you are learning momentum? Because force already is defined. Force, second law force, it says force is proportional to delta P by delta T. Average force. This is called average force. Delta P by delta T. What is delta P? Changing momentum. Changing momentum by time. So changing momentum means how do you write? Sometimes it is also important. Final momentum and initial momentum. This vector means P of bar minus P I bar. Time is scalar. This is called average force. Average force, which is a vector. Average force. Average force P of minus Pi by T. Well, for example, one-dimensional motion, no problem. Problem easily can be done. Final momentum and initial momentum. Similarly, force formula, main formula when you take force, but every aspect by counting terms you should remember. So P of minus Pi. Let us say final momentum is m. Let us say we take 1D motion. In 1D motion, in 1D, let us say we take average force, nothing but equal to P of final momentum, m into v minus u. I am not taking bars now. Let us stop bars there. Problem comes and take m into v minus u by t. V minus u by t is acceleration. So average force, you are writing M into A. Average force at force, you can say. Average force at force is given by mass into this is the famous formula for in second year, first year. Everybody should about know force is equal to Ma. M is mass, A is acceleration. M is mass, A is acceleration. So acceleration is F by M, you can write. So by calculating acceleration, one has to number kinematics equations. What is kinematics equations? We know V equal to plus 80. From that, students, A is equal to V. If you want to calculate acceleration, A is equal to V minus U by T. That you remember from the previous chapter that motion at straight line. Acceleration also can be calculated. Acceleration also can be calculated. Acceleration also can be calculated by V square minus U square by 2s. Because we know V square minus U square is 2s, we can calculate acceleration like this also. With vector notation, V bar minus U bar by T will write. Here V dot P will write minus U dot T will write. Like that. But let us confine now to one-dimensional motion many problems. So S is equal to UT plus 1 by T square also you can use to calculate acceleration. S is equal to UT plus 1 by T square also you can use to calculate acceleration. So these equations are compulsory even though this is chapter related to force, average force. Now, what is meant by these are the points now, main points of knowing these concepts. Okay, what is SI unit of force? SI unit of force is Newton. SI unit of force is Newton. Newton will have all those two classes, but very important. CGS unit is dyne. CGS unit is dyne. Generally, CGS unit is very less, but in mechanics we should know. CGS unit of force is dyne. Is a dyne. 1 Newton is 10 to the power of 5 dynes when it will be useful in problems with given CGS system. 1 Newton is 10 to the power of 5 dynes here. Okay? Force is a vector. Force is a vector. You can write force is a vector. F bar is nothing but equal to ma bar. Force is a vector. Force is a vector. Momentum is a vector. Force is a vector. So in physics, errors vectors, lot of importance is there. This is force. Right. Now, using all these formulas for coming problems now, I introduce my students, I introduce all each and every point that you see questions, you know what is important for all these questions. What is meant by equilibrium? Let us say body is there, number of forces acting in different directions, net force is 0, body will be in equilibrium. I told just now number of forces are acting in every direction like this, net force is 0. If net force is 0, body is in equilibrium. Equilibrium means it will be at rest, provided it is starting from rest. So body is in equilibrium. Equilibrium means always net force will make it 0. Body is in equilibrium. Equilibrium. Okay. So this is regarding the force formula. Then next, I am introducing a concept called impulse. Very important concept called impulse. Okay, students. Impulse means impulse in books is given by I in state book or in CBSE books they are given as J. So we have to let us say stick to I. What is impulse? During collision, whenever bound back collisions. So the collision occurs for a short interval of time. A large force acts during contact time. So this force is variable, not a constant force. No, actually earlier I introduced force equal to ma, that is a constant force. If you want to use equations of motion, A equal to V minus U by T, all these acceleration should be constant. V square minus U square is 2as, S is equal to U plus half T square, force should be constant. Most of the problems constant force only they do. But impulse, here force is variable. That's why we write average force into delta T. During collision it will happen, average force is delta. This is also vector because force is a vector. Is SI is second. SI unit is Newton second. SI unit is Newton second. CGS unit is Benz second. I am writing SI unit mainly Newton second. But impulse is also equal to this average force can be written as delta P by delta T. Average into delta. So delta P gets cancelled. Impulse one more formula is there. That is nothing but equal to delta P bar. Delta P bar means change in momentum. Delta P bar means change in momentum. You can write as m into V bar minus U bar. So let's see directions here. M into V bar minus U bar. So impulse, there are two formulas. Formula number 1, formula number 2. This is formula number 2. Impulse is also equal to change in momentum. Sometimes you have to equate both these formulae to calculate the velocities. Sometimes if you will ask you to calculate force, delta T will not be given. Mass will be given, initial velocity will be given, final velocity will be given. Then you have to equate impulse. The problem is like this. So this is average force to delta T. But impulse, what is one more unit, because impulse is also equal to change in momentum. Impulse is also equal to change in momentum. SI unit of impulse. SI unit of impulse is not SI unit of impulse. One more formula is not kg meter by second. Whatever momentum units are there, same units will come for impulse. So please students remember, impulse units is 1 Newton second SI unit and one more unit is kg meter by second. Both the units you have to remember because impulse is nothing but change in momentum. Area under force time graph gives impulse. This is another important thing. Area force time graph gives impulse or changing momentum. Gives impulse or changing momentum. Impulse, so many examples are there. You will let us say you fall onto the hard floor. You get more injury because cement floor means your reaction time will be the time of impulse will be very less. What is the formula? Impulse force in time. Time is very less, force will be more. So what will happen? You get more injury. So if you fall on sand floor, heap of sand floor, then what will happen? You will bounce back, taking more time. Delta T is more, force will be less. You get less injury. Like that, many examples are there on force on impulse like this. Many examples like this. The sun things are there in net because your body will not bounce back. You won't get injuries like this. This is regarding impulse. Backball police, WPG games. So last point I tell before trying the problems here. Last point I am telling you. So students, last point is nothing but Newton's first law we introduce, second law we introduce, second law and impulse also we introduce. Okay. Then next thing is Newton's third law. What is third law? Third law is nothing but internal action is equal to mass reaction. For every reaction there is equal to output reaction. These are internal forces. So now I told just now. Person falling on ground gives reaction. So you get injury. These are reaction forces act on pair of bodies. This will not create any acceleration. These are internal forces act on pair of bodies. This will come in three questions. And by taking the second law and third law, we will have conservation of momentum. We will have one last point, conservation of momentum. In this we will tell D. Conservation of momentum. What is conservation of momentum? Conservation of momentum. Conservation of momentum using second law and third law we generally do. Using second law and third law. So conservation of momentum says that if external force is 0, return external force is 0, total momentum remains constant. This will tell in collisions like this. Collisions will take like this balls and all that. That will land in virtuality collisions also. But I am telling you M1, U1, there is another body M2. This is colliding this one. U1 is greater than U2, collide this. So they are colliding each other here. exerting force on each other like this. They are moving with a velocity v1, m2, v. What it says is total momentum before collision m1 u1 plus m2 u2 is nothing but equal to m1 v1 plus m2 v. Total momentum before collision is first body momentum is second body momentum. m1 u1 plus m2 u2 is nothing but equal to m1 v1 plus m2 v. v1 is velocity with first body after collision, v2 is velocity second body after collision. u1 is the initial velocity of the first body before collision, u2 is the initial velocity second body before collision. So this application is given in gun-bullet problem. That is very important. Gun-bullet problem. Gun-bullet conservation of momentum applied. Gun-bullet problem. This is very important. Gun-bullet problem. They are given often in the examination. Gun-bullet problem. What is gun-bullet problem? The machine gun is there. Machine gun is there. A bullet initially at rest. Gun is after at rest. This is gun. Gun is heavy. This mass is m. Bullet mass is m. Initially at rest. Initially at rest means before firing, total momentum will be 0. After firing, this will move the velocity. Gun will recoil back. Gun will go back. That means bullet moves east. Gun goes west. So what is 0? Total momentum before firing is 0. Total momentum before firing is 0. After firing, individually they are having momentum. After firing, also total momentum is 0. What is small m? Mass of the bullet. What is capital M? Mass of the gun. What is v? Velocity of the gun. So 0. Total momentum before firing is 0. Total momentum after firing is also 0. But what is then m? M is mass of the bullet, v is velocity of the bullet, capital is mass of the gun, velocity of the gun. Therefore, this equation says that mv is equal to minus m. mv is equal to minus mu. So v, what is v? Minus mu by m. V is equal to minus mu by capital. What is m? Mass of the bullet. Mu velocity of the bullet. Capital mass of the gun. So this is called the formula for velocity of the gun. Recoil means going backward. That is mu by m. Magnitude. You take magnitude. Mu by m. This is conservation of momentum. So up to this we are told all these points. We'll come together and we'll solve some problems. Now, please see the formula. What the formula we told here today is first law. Second law F equal to ma, and one more important formula, two forces acting at an angle theta, resultant force how to calculate. You should know add a diagram of vectors, two forces acting at an angle theta. Sometimes they are asked. You can use diagram to F1 F2 cos theta. Theta is angle between F1 and F2. Sometimes problems can be resultant force can be asked. Two forces acting at an angle theta. I am applying two forces in a body, how it is moving. So perpendicular forces will be there, two forces acting at 960 degrees will be there. So body will move in different direction. That will learn in the two-dimensional motion. So that is the applying force it will move in, and not in let us say x-axis one force is there, y-axis another force is there. Body will move in different direction, making an angle with x-axis or y-axis like this. Okay, these are the formulae we learned. We are going to read problems. First problem, these students, a bullet of 10 grams leaves the barrel of the gun with a velocity of 600 meters per second. Leave the barrel of the gun. Barrel means it does not show you is the barrel. With the barrel of the gun, it is called barrel of the gun. So with a velocity, what is the velocity of the bullet? Do is 600 meters per second. Velocity of the bullet. Bullet mass is how much? 10 grams. 10 grams. If the barrel is given 50 centimeters long, it is given 50 centimeters long. Right. And it is leaving. Actually, here it is initially at rest. Actually, it is leaving. It is initially at rest. By leaving, its velocity is, let's say, u dash is 0. So it will leave 600 meters per second. Mass of 10 grams. And mass of the gun. What is the mass of the gun? Nothing but equal to 10 grams 10 grams. Capital mass of the gun. Capital mass of the gun is how much? Nothing but 3 kgs. Mass of the gun is nothing but how much? 3 kgs. Okay, friends. Now what is asking? Value of impulse applied to gun. Impulse means what? Initially gun is at rest. Finally gun is attaining momentum. MV. Impulse means changing momentum only. Initially gun is at rest. Finally momentum is MV. Changing momentum is MV only. You are asking MV. How to calculate MV? Impulse means impulse of the gun. Impulse, directly impulse for gun. Gun means what? From the formula MV. But V velocity of the gun is not given. But MV is nothing but what? Nothing but equal to minus MV only. MV is nothing but what? Minus MV only. What is minus M? 10 grams. Grams are converted to kilograms. How to convert kilograms? 10 by 1000 or 10 and 10 power minus 3 kgs. And velocity of bullet is how much? 600. This is nothing but equal to 6,000 into 10 to the power of minus 3. That is nothing but equal to 6 into 10 power 3 into 10 power minus 3. The answer is 6 Newton second. That's 3 minus 3. 6,000 10 power minus 3. 6 into 10 cube. 6,000 is 10 power minus 3 is the problem. Based on impulse. But he is using the language impulse. Impulse means moment, not momentum, changing momentum. Changing momentum for gun is MV only. Because he is at rest. Finally MV. So 0 minus of minus MV. So MV is equal to minus MV. So this thing is 6 Newton. Magnitude of the impulse is nothing but equal to 6 Newton second here. Okay, this is our first problem. Second problem. Please see the second problem. 3 forces, 10 newtons, 8 newtons, 6 newtons are acting on a particle of mass 5 kg. On a particle of mass 5 kg. 2 forces F2 and F3, what is F2? 8 newtons. F3 is how much? 6 newtons. Are applied perpendicular so that particle remains at rest. Particle remains at rest. That means it is equilibrium. For suppose the force F1 is removed. If the three forces are there, that particle is remaining at rest. But suddenly if you remove force, what will happen? The body will move. The body will move uniform motion with acceleration. Let us show this one in diagram. There are 2 forces F2, this is nothing but F3. This is F2, this is nothing but equal to F3. F3 is how much? 6 newtons. F2 is nothing but how much? 8 newtons. When the 2 forces are acting on the body now, on the body 2 forces are acting. So one more force is acting, so that the body is at rest. Actually 2 forces are acting, the body will move in the right direction. I told just now, last point I told. The 2 forces, how they are acting? Perpendicularly they are acting. How they are acting? Perpendicular, 90 degrees between them. The body moves in the right direction like this. Now, if at all, third force is applied, exactly opposite direction like this. Exactly opposite direction like this, the body will remain at rest. Body will remain at rest, provided the force is acting like this. F1 force acts like this. F1 is opposite to Fr. Then F1 minus Fr will be 0. Body will be equilibrium. That is for only for data here. But only thing is, for suppose F1 is removed. If F1 is removed, hello? If F1 is removed, then body will move Fr. How to find Fr? By Pythagorean you can find out, but they are perpendicular. Pythagorean theorem you can use. F2 square plus F3 square. You can't use 6 are equal to 64 plus 36. Root of 100. Therefore it will become 10 Newton. Resultant force is 10 Newtons. How to find acceleration now? After finding this, acceleration is given by the resultant force by divided force by mass. Students, if the two forces are there, don't use only one force, 6 Newton and 8 Newton. After using these two forces, third force, the body is remaining at rest. The body here, body is remaining at rest here. This is direction, please see the figure properly, exact opposite direction. So this force how much is there? This also F1 is also equal to how much? 10 Newtons. Then body will remain at rest. If this is removed, this is the force remaining. If 10, mass of the body is 5. Then acceleration is how much? 2 meter per second square. Acceleration is 2 meter per second square. These are all given in our examinations. These models, 4 years, 5 years papers. If you are dealing at daily main level or Eamcet level or NEET level, if you are doing these problems, all will help you in order to build up different types of problems. Let us go to next problem now. Here, one more problem. An average force of 125 newtons. An average force of 125 newtons is applied on a machine gun firing bullets, each of mass 10 rounds at a speed of 250 meter per second. To keep it in position, to keep it in its own position, the number of bullets fired per second by the machine gun is 10. So this is force. Force, what is the formula I use? Force is equal to ma. But the only thing is, m is called what? Mass of each bullet. But how many bullets is emitting per second here? That's what is telling. So what you do is, a means v minus u by t you write. A is equal to v minus u by t because n number of bullets are there. The average force. What is n? Actually, one bullet force is this much only, m v minus u by t only. 10 bullets are emitted per second. Time is how much? 1 second he has given. Time is given as 1 second. Average force. The average force is equal to how much? 125 newtons. Average force of 125 newtons is applied in machine gun firing bullets each of mass 10 grams at a speed of how much? 250 meters per second. That means final speed is 250 per bullet. Final speed is 250. Initial speed is rest, nothing. Starting from rest, bullet, starting rest, and coming out of the gun with a velocity 250 meters per second. Time is 1 second. Force is given. Number of bullets. How many bullets? Number of bullets only is asking. So average force is how much he has given? 125. 125 is nothing but equal to mass of the bullet 10. Don't forget to convert it to SI unit. 10 in 10 power minus 3. Final velocity 250 minus 0 by time 1 second into number of bullets is equal to 125. So now do calculation. 125 is nothing but equal to 10 into 10 power minus 3 into 250 into 10. 125 goes 2 times in like this. So is nothing but equal to get 1 2 in 20 into 10 power minus 3. 20 into 10 power minus 3 here. N is equal to how much? 1 by 20 into 10 power minus 3. Therefore, N is equal to, this goes up, 1000, 10 power minus 3 goes up, minus goes up, 1000 by 20. So how many bullets now? N is nothing but equal to 50. So do the calculation correctly, even though we are bullet concept, sometimes we miss the calculation. Calculation is also one of the part we have to take care of by doing the complex examination because time will be less. So N is equal to 50. So by explaining to you will take little time, but by doing we should do quickly, somewhat 2 minutes and like that. This is third problem based on force formula. Going to next. Right, you see force acts for 20 seconds on a body of mass 20 kg starting from what? Starting from rest. After which force ceases and then body describes 50 minutes in the next seconds. What is the value of force? Again I am calling. Please see the question. Force acts for 20 seconds on a body of mass 20 kg. When force is acting on body, definitely it will move with acceleration. Starting from rest. U is equal to G. But after some time, it will attain some velocity. But after which, after some time, force ceases. Force ceases means force is becoming 0. And then body describes 50 meters in the next 10 seconds. Then what is the value of force? So this is having uniform motion as well as non-uniform motion. So there is a body here. Starting, there is a body here. There is a body here. Starting from rest. Okay, force acts on the body. Force acts on the body. Body will travel from this way. Body will travel for 20 seconds. How much time it will travel? 20 seconds and attain the velocity v here. Here initial velocity 0, it attain the velocity v. How will it attain velocity? Because force is there. After this, what is happening now? Force ceases here. Force ceases. Next it is traveling how much distance? 15 meters. In the next time how much it is? 10 seconds here. There are 2 times here. But please work out this problem in 2 parts. First part, force is there. Second part, force is not there. First part is non-uniform motion. Second part is uniform motion. Please, I am telling you. First part is non-uniform motion. Second part is uniform motion. So initial at rest, force formula we are using. I want to calculate this velocity. So that idea you should get it. V minus u by v. Force I don't know. Mass. Body mass how much? 20 kg body is here. 20 kg V. You have to find a value of unknown. U 0. Time is 20. So what is the force answer you are getting? 20 gets cancelled. So force is equal to V again. The magnitude of force is equal to velocity again. This is non-uniform motion. Next part, same velocity. Everywhere velocity is same because force is flat here. Force is 0. Toward the motion, force is 0. Toward the motion, force is 0 now. Force is 0 means it will move uniform velocity. Distance traveled. Yes, well, distance traveled how much? 50 meters. Then time is equal how much? Time is equal 10 seconds. Time is equal 10 seconds. Time is equal 10 seconds. 10 seconds time is given. Uniform motion now this is. Uniform motion. Don't use S is equal to t plus half a t square now. S is equal to what the velocity stands here? Velocity is v. S is equal to v to t. What is S is equal to? V to t. So v is equal to what here? F here. S is equal to how much? 50. Uniform motion. Acceleration won't be there. Uniform motion means acceleration is 0. S is equal to 50. V is equal to F. F is what calculated. Time is how much? 10 seconds. Force value is how much now? 5 meters. So this problem is non-uniform, a part is non-uniform motion and uniform motion. Calculate if you use along with this, the problem will come here. This is another good problem, friends. Right, now, next question. So there is a theoretical question here. In 2 different experiments, an object of mass 5 kg moving with a speed of 25 meters per second hits 2 different balls and comes to rest within first 3 seconds, second 5 seconds. In 2 different experiments, an object of mass 5 kg moving with a speed of 25 meters per second hits 2 different balls, 2 different types of balls and comes to rest within 3 seconds and second 5 seconds respectively. So times are different. So he is asking, what is the question? Choose the correct option. Please see carefully, choose the correct option of the following. A. Impulse and average force acting on the object will be same for both the cases. Impulse and average force acting on the object will be same for both the cases is telling. What is impulse? Impulse is nothing but the average force into delta. Time is different, force also will be different. Because in this process, impulse will remain constant. What is constant? In this process, impulse is constant. Time is different, time is less, force will be more. First case, delta t is given how much? 3 seconds. Delta t1. Next, delta t is given how much? 5 seconds. Then definitely force will not be same. So force will not be same. In both the cases, F1 is not, F average will not be equal to F average. First case will not be equal to F average. Second case, definitely. So first answer is wrong. Impulse and average force acting on the object will be impulse and average force acting on object will be same. Impulse will be same, but average force will be same. B. Impulse will be same for both the cases, but the average force will be different. This is correct answer. Impulse will be same, constant. Average force will be different. That is correct answer. C. The average force will be same. That is not correct. You can take it out. Average force will be same for both cases, but impulse will be different. That is wrong. So lastly, average force and impulse will be different for different cases. So impulse, during this process, impulse remains constant. This is variable. Force is increasing, delta T is decreasing. Delta T is more, force will decrease. These two factors will change. Force, average, and delta. So correct option is what? Impulse will be same for both the cases, but the average force will be different. This is a critical question. Now next question. Based on impulse, a ball of mass 0.15 kg hits the ball with initial speed of 12 meters per second and bounces back without changing the initial speed. Without changing the initial speed. There is a ball here. There is a ball here. A ball of mass. A ball of mass 0.15 kg. This is 0.15 kg is hitting the ball with a velocity u and bouncing back with same speed. Bouncing back with same speed. Bouncing back with same speed u. Back means minus u or t. Forward direction positive. Backward direction negative. So forward, this is positive plane, this is negative. Ball is going back. Force applied by the ball during the contact. What is the force applied during the contact? During the contact is force. Average force how much is that? 100 newtons. Average force is 100 newtons. Calculate delta T is also. I told earlier today's lecture in theory, impulse is equal to change in momentum. Impulse is equal to change in momentum. Impulse is equal to change in momentum. Impulse is nothing but equal to change in momentum. Change in momentum when you are doing. Impulse is equal to what? The average force in that is one formula. Impulse is also equal to change in momentum. It is also equal to change in momentum. Change in momentum means final momentum minus initial momentum. Final momentum is minus u minus of plus u. So therefore we are going to get minus 2 mu. This is impulse exerted by the ball. This is impulse exerted by the ball. This is the thing, impulse. This is equal to the average force into delta T. The average force into delta T. The average force. What is the average force? 100. 100 into delta T. That should be equal to magnitude you take. Magnitude you take delta T. Magnitude is nothing but 2 mu. To return 2 mu. Magnitude we are taking. Impulse exerted by the ball we are taking. Delta T is equal to 2 mu. 2 mu. So 100 into delta T is nothing but equal to 2 mass of the ball. How much? 0.15 kg. What is the velocity? What is the velocity? 12. 15 into 12. So 2 into 0.15. 2 into 0.15 is how much? 0.30 or 0.3 into 12. This is 100 into delta T. So therefore calculation will become delta T will become equal to 12 into 3, 3.6. 3.6 divided by 100. 3.6 divided by 100. So I am showing the answer here. Delta T is nothing but equal to. So 3.6 into 100. That 6 by 100 is 0.36. 3.6 by 100 is nothing but equal to 0.036 seconds. 0.03. This is the option. 0.036. Such a good problem. So impulse both the formula we have taken. So only thing is it should not take change moment 0. Because going in this direction, coming back in this direction. You have taken change in momentum, not adding these velocities. Change in velocity. M into minus 2 minus of plus 2. So minus of plus 2 minus 2. That will become minus 2. This is impulse exerted by the minus 2 mu. This is impulse exerted by the ball. Okay, students, impulse exerted by the ball means plus 2 mu only. Action reaction forces. This is the one important question given here. No, this is still easy. A batsman hits back a ball of mass 0.4 kg be straight in the direction of the border without changing its initial speed of 15 meters per second. What is impulse in hours? This is integer type question. So impulse means, now what is impulse? Impulse is nothing but changing momentum. We have not one force, we have not one time. But impulse units are Newton second. Yes, changing momentum of units also can be Newton second or 18 meter per second. So m into, just now I told. So it is same diagram. So it is hitting the ball, it is the back. The back is there, back is there here, and going back like this, back on the track. Like this, going 50 and coming back minus 50. So 50 minus of minus 50. So impulse is nothing but equal to mass is 0.4 into 30. Impulse is nothing but equal to 4 into 3, 12. Answer is 12 Newton second. This is indeed type question. That's why alternatives are not there. This is nothing but impulse is nothing but equal to 12 Newton second. Impulse units can be given even though we are using changing momentum formula. 12 Newton second can give or 12 kg meter per second also we can give. There is nothing wrong in this. Okay students, today we learned different problems on the impulse and force and all these problems. Thank you.